Welcome, Year 11s, to the Reactions of Acids practice questions, part of the Exam Technique series playlist on the Science Revision Coach channel. Please don't forget to subscribe, like, and share this video so this channel can continue to grow. Again, I am going to be using the exam question approach that I have discussed in previous videos on this playlist. Please pause the video now if you would like to have a closer look and listen. If not, you can carry on to the next question. So question 1, this is an extended writing question, so it's a 6-marker. Remember, you will have a 6-mark question in every single one of your science papers, at least one. Higher tier, you may have more than one 6-marker essay question. You could also get some 4-mark questions in your exam as well. So this question is about making copper salt. So straight away, that's related to the required practical making copper sulfate. The figure below shows the apparatus given to a student. And so the key thing is to look at the apparatus and make sure you understand how it's used and what it's used for. So we've got a stirring rod, a spatula, a beaker, filter funnel with filter paper, evaporating basin, Bunsen burner, tripod, gauze, and a heat-proof mat, and a conical flask. And obviously all those bits of equipment would be useful in this required practical. Outline a safe plan the student could use to make pure dry crystals of the soluble salt copper sulfate from the insoluble metal oxide and dilute acid. So straight away, I would be writing the chemical equation so I know what is being made. I should remember what ingredients I need, and they've given me a hint to some of the ingredients. I should also remember what I need to do as I am adding these ingredients together and what equipment I will need. Now, I did a video on memorizing the steps in this required practical, and I will put a link here on the screen so that you can access this video if you have not already made an interactive revision tool on this topic or on this specific required practical. But this time I'm not going to write a model answer because I can show you the model answer from the mark scheme. But this is an opportunity for you to practice your writing skills. So give yourself 6 minutes, have a stop clock. You all have one on your smart devices. Give yourself 6 minutes to write an answer. But before you do that, one of the things that I would say you could do to help yourself in terms of annotations is to number the equipment in the order that you'd use it. And then that way, you know, you've used every bit of equipment. And that way you're also thinking about what you're using the equipment for. And therefore you're less likely, if you like, to miss out any key steps. So give yourself 6 minutes, start writing your plan, and then when you're finished, you can check the mark scheme. So you can pause the video now and start writing. Okay, so now that you've finished your plan, have a look at the screen for the mark scheme. On the left-hand side, that is the level or the band that the examiner is going to put your answer in. So the examiner reads your response, and then they decide whether it's in a level 3, level 2, or level 1 band, or none of the above. And you can see that for level 3, you need to write a coherent method described with relevant detail, which demonstrates a broad understanding of the relevant scientific techniques, procedures, and safety precautions. The steps in the method are logically ordered with the dependent and control variables correctly identified. The method would lead to the production of valid results. For a level 2 response, the bulk of a method is described with mostly relevant detail, which demonstrates a reasonable understanding of the relevant scientific techniques, procedures, and safety precautions. The method may not be in a completely logical sequence and may be missing some detail. And level 1 response, simple statements are made which demonstrate some understanding of the relevant scientific techniques, procedures, and safety precautions. The response may lack a logical structure and would not lead to the production of valid results. And obviously, if you've written nothing of any note, you get 0 marks. So that's what the examiner does. They decide which band you're in, and it will be based on some of the indicative content, which we can see here. So naming the chemicals. Now, as I said, writing a word equation or a balanced equation will actually help you. So for me, writing a balanced equation or writing a word equation will have, if you like, indicated the chemicals involved. Correct use of apparatus. So all the apparatus that was drawn on in the figure is mentioned, and how to use it. So that's a useful reason why you should number the apparatus in the order you're going to use it. And then the method. So key phrases: add excess copper oxide, which is the insoluble base, to the acid, heat the mixture, filter the mixture, a method to evaporate some of the water, and making sure that you are able to get crystallization occurring. And then safety aspect is wearing safety glasses or goggles, making sure that you're aware that sulfuric acid is corrosive, that warming instead of boiling the acid is more safe, and then holding the beaker containing the warm mixture with tongs to make sure that you're not going to risk yourself with burns. So those are the kinds of things that we're looking at. Now, that doesn't mean that you need to mention all the safety aspects. It just means that you need to be aware of some. The method, you need to have it in a coherent order. You've got to mention key things like filtration, heating, and crystallization, and so on. So if you number the equipment in this case, you should have found it a lot easier to gain 6 marks. And this should be a really easy question to get full marks on. And remember, in a 70-mark paper, that's just under 10%. That is easily a grade. Okay, so now we move on to the next question. Question 2. Some students investigated the change in temperature as sodium hydroxide solution is added to dilute sulfuric acid. Now, they've given you a method. This is the method used. Put 25 centimeter cubed of dilute sulfuric acid into a polystyrene cup. Why polystyrene? Polystyrene is a good insulator. This is what I would be annotating, by the way. Step 2, measure the initial temperature of the dilute sulfuric acid. So you obviously want to measure a temperature change. Step 3, add 4 centimeter cubed of sodium hydroxide solution to the dilute sulfuric acid. So that's going to be a neutralization reaction. So it's exothermic. Step 4, stir the mixture. And step 5, measure the highest temperature of the mixture. So you're definitely looking at a temperature change. An increase to the surroundings, an exothermic reaction. Step 6, repeat steps 3 to 5 until 40 centimeter cubed of sodium hydroxide solution have been added. So you're adding it at increasing concentrations. Figure 1 shows the apparatus the student used. So again, I won't just look at it and ignore it. I'll annotate any details so I can see that they're adding the sodium hydroxide solution via a burette so that it's controlled. I can see the polystyrene cup, I can see the thermometer, but there's no lid. So that's interesting. So am I actually capturing all the heat transfer? So that's something to make note of. And then it says part A, the volume of sodium hydroxide solution is variable. Which 2 words can be used to describe this type of variable? So again, it's basically a basic recall question based on your knowledge of how science works or your investigation skills. So again, you can pause the video now and write your answer. And now we're moving on to part B. The dilute sulfuric acid has an initial temperature of 24 degrees Celsius. Figure 2 shows the highest temperature. So you look at the thermometer. Can you see what it says? It says calculate the change in temperature. So again, you can pause the video now and work out what the change in temperature is. And now that you've done that, let's move on to figure 3. Figure 3 shows the students' results. And you can see the highest temperature in degrees Celsius across the volume of sodium hydroxide solution added in centimeter cubed. So again, make a note of what you can see in terms of the trend. And it says part C, determine the volume of sodium hydroxide solution that gives the highest temperature change. Use figure 3 to help you answer this question. So again, I'm going to ask you to pause the video and see what you think the answer is based on what you can see on the screen. And then part D, in figure 3, the temperature when 16 centimeter cubes of sodium hydroxide solution is added is anomalous. Suggest one error that could have been made in the method that would cause this anomalous result. So why is it that at 16 centimeter cubed, the highest temperature is actually lower than what we would predict it to be if it followed the trend? So that's what you're trying to answer. So again, you can pause the video here and write your answer. Right, part E. The sodium hydroxide solution in this investigation contains 80 grams per dm cubed. The students used 40 centimeter cubed of sodium hydroxide solution. Calculate the mass of sodium hydroxide in 40 centimeter cubed. So you've got to think about what equation you might need to use and think about any conversions that you might need to think about. And again, pause the video here so that you can then do your calculations. And remember, it's 3 marks, so it's really useful to show your working out. You can pause the video here. Right, so you should have all your answers written on a piece of paper. So hopefully now, as you see the mark scheme on the screen, you can mark your responses. I'm going to ask you to pause the video so you can have a look at the answers and check your responses. Right, hopefully you can see where you have gone in terms of the questions, whether you got them mostly right, whether you have not got them right. Remember that it's roughly 1 minute mark. It's a little bit over a minute, but it's roughly a minute per mark. Remember that you've got to use all the clues in the question. I've deliberately picked questions that cover quite a number of topics. So reactions of acids, reactions of metals with acids, and the 2 required practicals that were specifically mentioned, the copper sulfate crystals and the measuring temperature change. So we've covered quite a lot with just 2 past paper questions. Remember to do a lot more past paper questions, and I've put a message in the description box of where you can find more past paper questions for free online. And lastly, I would ask you again if you can subscribe, like, and share this video. That would be much appreciated. And I'll wish you all the best and good luck. Bye.